Welcome to Advanced Algebra, everybody. My name's Miss Brinley. Some of you may know me already. I have the honor of doing the very first chapter in our Advanced Algebra journey. So just as a general overview, this whole entire year is about functions. So what we're going to do is we're just going to introduce the idea of functions today and how we can transform them so we can keep the same shape of the function, but we can stretch it and flip it over the x-axis and we can move it around. So I'm going to show you guys introduce you guys to some of the rules about how to do that. So let's just take four basic functions that we have right here. The first, we just have f of x. If you guys remember from Algebra 1, f of x is just a fancy word for y. And it means that y, this is a function, so we're just calling y f of x here. So I've made these tables, so if I have a function f of x equals 1, that means the y value is always going to be 1. So in this table, no matter what x is, y is always going to be 1. So let's see what that's going to look like if we sketch a graph. Right, so if I sketch the point negative 2, 1, negative 1, 1, 0, 1, 1, 1, and 2, 1, I get something that looks like this. Right, it's a horizontal line. And that is what we will call, guys, a constant. We're going to call that a constant, and the reason is that there's no x in it. The y value is always the same, right? In this case, it's 1. Okay, let's look at this simple function, which is f of x equals x. So if I plug negative 2 in for x here, that means I also get negative 2 for f of x. So that's going to be the case no matter what x value I plug in, I'm always going to get the same f of x value. So let's see if we sketch this, what is this going to look like? Negative 2, 2, negative 1, 1, etc. I'm going to get myself, and this is normally where I'd be asking you guys to answer the question, but since you're not here, this, most of you would agree, is a line, right? So we're going to call this, no surprise, a linear function. Okay, so now we've got our constant, we've got a linear function. If you guys remember on this third one, what these two bars mean, what they mean is absolute value. And if I plug an x value in and it's negative, it means that the absolute value symbols are going to turn it positive. So if I plug in negative 2 here, that's going to get me a positive 2. Right? So if I plug in negative 1, it's going to get me a positive 1. And what if I plug in positive 1? It doesn't turn negative, it's always going to be positive. So this one's kind of interesting. There's a certain shape. Oh, sorry, this is 1. Thank you. Okay, let's see what this looks like. A certain shape that I have. And absolute value is always going to have this shape. And most people describe this as a V shape. So absolute value is V-shaped. Right, so sorry, this is an arrow. So this is absolute value right here. And these are all things you probably learned in Algebra 1. But we're going to think about them in different ways in Advanced Algebra. Okay, the last one is f of x equals x squared. So you may have remembered you finished Algebra 1 with this. I know geometry was in between, so you may not remember. But if I plug negative 2 in and I square it, I get a positive 4. Right? If I put negative 1 in and square it, I get a positive 1. So let's see what that's going to look like. Now maybe some of you remember from Algebra 1 what the shape is of a squared function. It's called a parabola, and it's shaped like a U. So it's U-shaped, and it's called a parabola. And there's actually a name for these squared functions, and they are called quadratic functions. So this stuff you may already know, but I have a feeling that this part is going to be new. So each of these functions, if you notice, they're bare bones. It's plain old constant, or plain old x, or plain old absolute value x, or plain old x squared. There's no numbers next to them. There's no 2 in front, or plus something, minus something. So when we make changes to these functions, we are always going to start with these bare basic functions, and they're called the parent functions. So any changes that we make are going to be, the parent function is going to be our anchor. It's going to be our starting point. And the coolest thing about this is no matter what function you use, there are very specific transformations that always do the exact same thing to the functions. So you just need to learn one set of transformation rules, and they can apply to every single function you're going to learn about this year. Super, super cool. Okay, so let's start with something here. Okay, so if I have a graph, right, and someone says, describe the type of transformations, describe the transformations, the first thing I want to do is identify what family is it in. Is it in constant, linear, absolute value, or quadratic? Well, I can tell by the shape here, it's V-shaped. So we know just from looking at it that it's an absolute value function. Now, does it look exactly like the parent function up there? Well, no, right? It's still the same shape, but if you notice, there's some things that are different. If I look at the parent function from the previous page, I can see that the point, this bottom point here, which is called the vertex, is at the origin in the parent. So if you notice, this one's actually 1 unit higher, right? So the vertex is actually 1 unit higher from the parent. And then if you notice something else, this one's a little trickier to notice. If I look at the distance between the vertex and the next point, I notice on the parent, it's just over 1, up 1, over 1, up 1. But let's look at this. This one's over 1, up 2. So this one is twice as tall. So there are some changes. So it is true that it's absolute value. So watch what I'm going to show you guys. What does that translate to in the equation? Well, there's our parent, right? If I want to make it twice as tall, I'm going to put a 2 out here. And if I want to make it 1 unit higher, I'm going to put a 1 out here. So notice I started with the parent function, and I put extra stuff on there once I realized what the transformations were, right? And I can tell just by looking at this and comparing it to my parent graph what the differences are between the two. Okay, let's do some graphing of our up. Okay, so here we're going to talk about horizontal and vertical translations. I didn't write this. Horizontal translations move left and right. Vertical translations move up and down. I'm only going to do one example here, but then at the end, we're going to do one with both. So what if I want to graph this function? f of x equals x squared minus 3. So I'm just going to plug in these x values, and I'm going to do the first one, and then I'm just going to fill in the rest because I'm going to figure you guys can do the arithmetic here. So if I have f of x equals x squared minus 3, that's going to be 4 minus 3, which is 1. And if I do that for all of them, I get this. Those are my f of x values or y values once I plug in those x's. So let's see what that looks like. Let's just graph these points. And then what we're going to do, we can see it says x squared. So we know this is a quadratic just from the equation. So we're going to compare, maybe I'll even sketch I'll sketch the parent function as well. So this is my graph, f of x equals x squared minus 3. And then you already have the parent graph, so I'm just going to sketch it real fast. This is what the parent graph looks like. So let's compare these two graphs. Well, they seem to have the same basic shape, right? They're not, one of them's not stretched out or shrunk down. They're the same exact graph, only what I did here is I picked up this parent function and moved it down 3. So if I'm going to describe the transformations, I'm going to say that it is shifted or translated, shifted's a little more casual, 3 units down. Right? So if I take the parent, shift it 3 units down, I get x squared minus 3. Okay, now we're going to move to the other boards. Super exciting. Okay guys, one of the cool things you can do here, you can actually flip graphs upside down. And we call those reflections. So this time we're going to take an absolute value function just for the sake of variety. So this is an absolute value function, I can tell by the equation. And I'm going to graph the parent and also the problem right here, negative absolute value x. So we know we can just copy these from our first page here. This is what it looks like for the parent function. So let's sketch that. Actually, you know what? I'm going to be consistent and use black for the parent function because I did that last time. Let's do 2, 1, 0, 1, 2. And we can just copy this. This is what it looks like from our page 1. So that's f of x equals absolute value x. Okay, what's going to happen now if I make it negative on the outside? So what if I say negative absolute value negative 2? Well, that's going to be, we know that the absolute value of negative 2 is 2. Right? So that's going to be a negative 2. Same again, negative absolute value negative 1 is equal to negative 1. 0 is lucky. Negative absolute value of 1 is equal to negative 1, right? Because absolute value of 1 is 1, and then the negative's on the outside. And then negative absolute value of 2 is negative 2. So I'm going to graph that in purple, even though I didn't write it in purple here. And let's see what it looks like. We know it's going to be V-shaped because it's absolute value. But how is it going to differ from the parent? This is f of x equals negative absolute value x. How's that different, guys? Well, we can see that it's turned upside down. It's the exact same graph turned upside down. Except we can't really say turned upside down because that doesn't sound sophisticated. And mathematicians are sophisticated. So another way to say turned upside down is to say reflected across the x-axis. That's a fancy way of saying turned upside down. So this, compared to the parent, is reflected across the x-axis. Okay, guys, we're going to do one more of these, and then we're going to use Desmos for the grand finale, which I don't know if you guys have used Desmos, but it's really, really useful. Okay guys, what if, so here notice we've done some shifting of the graphs. We moved a graph down over in example 2. We reflected across the x-axis in example 3. What if we want to make our graphs taller, or we want to shrink them and make them flatter? Well, let's do a little exploration here. I'm just going to copy these from my parent table. And I'm going to just sketch my parent graph real quickly right here. This is where, like we said, we always compare all of our new graphs, our transformed graphs, to the parent. So it can be handy to have the parent graph as well. Okay, so what if I want to graph f of x equals 1/2 x squared? Well, if you notice, I already have the x squared here. So 1/2 x squared is going to be 1/2 times 4, which is 2. Right? This one's going to be 1/2 times 1. This one's going to be 1/2 times 0. This is going to be 1/2 times 1. And 1/2 times 4. So let's graph these and let's see how it looks different. Okay, let's notice something here. This is, f of x equals 1/2 x squared. So what do you notice about that? Sorry, this is not a very pretty picture. Well, if you notice, it's flatter than the parent. It's like someone took a trash compactor and compacted it down. Right? So it's actually half as tall as the parent function. So what we're going to say is a vertical shrink, and when we want to say half as tall, we're going to say by a factor of 1/2. That's another way of saying half as tall, but in a sophisticated way. Okay, guys. Hopefully you're making predictions about what it's going to do if there's a 2 in front of it. So again, now I have 2x squared. Well, I know x squared is 4, so I can say negative 2 squared is going to be 8. 2 times negative 1 squared is going to be 2. So that's what I'm going to get when I do the arithmetic. So let's see what that looks like compared to the parent function. So this is f of x equals 2x squared. So just like with the 1/2 x squared, it's like someone took the parent and trash compacted it and made it flatter. Look at the red graph. It's here, it's like taking the parent function and stretching it like a piece of silly putty, right? So if you guys see that, it's actually twice as tall as the parent graph. So what we're going to say here is a vertical stretch by a factor of, now twice as tall is going to be a factor of 2. Okay, so notice all these graphs, we did one transformation at a time. So now I want to show you guys something called Desmos, which is a free graphing utility that you can get online. So everyone, I'm going to do this. My videographer will move the camera. Okay guys, so I want you to go to any browser, any Google or Yahoo or whatever browser you use. Sorry, it's warming up. There it goes. So we're going to do this last example on Desmos. So you're not going to be able to see me, but you'll be able to see what I'm doing. Let's wait for it to show up. Okay, so all I need to do to get to Desmos is type in www.desmos.com. And it's called Beautiful Free Math. So what I can do is I can just say graphing calculator. All this is basically a graphing calculator. So when I say graphing calculator, it's going to show up like this. So the last example, guys, example 5, says graph the parent function and then graph f of x equals negative absolute value x plus 2 minus 3. So first I'm going to graph y equals absolute value x. So watch what I can do. I can show the keyboard by clicking that little keyboard icon. And I can literally just type in y equals. Now I want the absolute value function, and notice it's not here. So what I'm going to do, I'm going to type functions, and I'm going to go to miscellaneous. Oh wait, I take it back. The absolute value function is there. Sorry guys. I don't need this. Okay. The absolute value function is there. So I'm going to go like this, y equals absolute value, and I'm just going to type in x. And that should look familiar, right? That's our parent function. Now, the example says, I can graph more than one thing on here at once. So example says graph f of x, which is just y, equals negative, right? So we just write the minus sign, absolute value, right? X plus 2, and then I'm going to click outside the absolute value, and then the minus 3 is on the outside. So now I'll collapse this. So guys, let's sketch that, right? So I'm going to head over to the board again because you guys have this on your computer. So let's sketch this, both these functions, on the graph provided in the very last example. So I'm going to shut this off. Okay, so if we sketch it, we can see that our absolute value parent looks like this as usual, like it always does. And our new function looks like this. Right, so if I sketch this, it's going to look like that. So this is f of x equals negative absolute value x plus 2 minus 3, and this one is f of x equals absolute value x. Okay, so let's look and see. Let's compare what's happened here. Well, one thing you'll probably notice is that it is turned upside down. So we can say it's reflected across the x-axis. So that's one thing. And let's look at the vertex. The vertex of the parent is at 0, 0. But where's the vertex of the new function? Well, it looks here that the vertex is at negative 2, 3. So you can see that it's actually shifted to the left 2 and down 3. So that's the second thing that's happened. So the very last thing I want to do is just sketch out this equation. Here's our parent function, y equals absolute value x. So if you remember from the lesson, what makes it turn upside down is a minus sign out here. Okay? What makes it go left 2 units is actually to put an x plus 2 in here. That seems counterintuitive, I know, because it goes left when it says plus 2. We are going to be doing a lot of exploration on that. And then we notice it goes down 3 units. So there is actually the function that we can see matches this right here. So that's the lesson for today, guys. At the end of the note sheet, there are 2 practice problems I would like you guys to do. And so when you upload the notes, you can also fill in the practice problems as well. All right, guys, see you soon.